All right, in this video, I want to continue my series of trig proofs by coming up with the cosine angle addition formula. And what you'll see is this formula is really just a consequence of our sine angle addition formula, which I proved in the previous video here, and two facts about the graphs of cosine and sine. The first one is that the cosine of t is equal to the sine of t plus pi over 2. And the second one is that the cosine of t plus pi over 2 equals the negative of the sine of t. And you're like, whoa, I've never seen those before. Yeah, that's true, but I think I can convince you of them pretty quickly. For this first one, start by thinking about the graph of sine of t. Maybe you can picture that in your head. And then think about, wait, I don't want the graph of sine of t. I want the graph of sine of t plus pi over 2. What does this pi over 2 here do to the graph of the sine of t? Well, maybe if you're good with function transformations, you'd understand that this is a horizontal transformation, and it's going to shift my graph to the left by pi over 2 units. So picture the graph of sine of t shifted to the left by pi over 2 units. What do you come up with? Hopefully the graph of cosine of t. Don't believe me? Here's a picture. In red, we have the graph of sine of t. If I shift that to the left by pi over 2 units, it lands right on top of this graph in blue, which is just the graph of the cosine of t. Therefore, the cosine of t is the exact same as the sine of t plus pi over 2. Okay, but what if we were shifting the graph of cosine of t? What if I started with the graph of cosine of t and shifted it to the left by pi over 2 units, because a horizontal transformation, when you have a plus pi over 2 here, moves it to the left by pi over 2. What would that look like? Well, let's go back to Desmos. I start out in blue with the graph of cosine of t, and I shift that to the left by pi over 2 units. That gives me this graph in green here. What is this graph in green? You don't recognize it. Well, it's pretty close to the graph of sine of t, shown in red. It's just reflected vertically. How do you reflect a graph vertically? All you got to do is throw a negative out in front of it. So if I start with the graph of cosine of t and shift it to the left by pi over 2 units, I almost end up with the graph of sine of t. It's just reflected vertically, hence this negative sign here. If you'll grant me these three facts, I can prove this to you pretty easily. The way I'll do it is I'll first use this fact. I want to know the cosine of some angle. That angle happens to be a plus b, but don't let that throw you off. It's just some angle. Well, this fact tells me that that's the exact same as the sine of whatever that angle is. It happens to be a plus b, but don't worry about that, plus pi over 2. Okay, I guess that's true, but I don't really see how that helps. Well, what we can do is think about this sum. Right now it's a sum of 3 terms, but we can think about it as it's really just the sum of 2 different things. One of those things is an a, and the other one of those things is b plus pi over 2. Why would you want to think about it as a sum of 2 different terms instead of 3 different terms? Because I have this angle addition formula, which deals with the sum of 2 different terms. Yeah, in my formula, they're an a and a b, whereas down here, they're an a and a b plus pi over 2, but that's fine. I could just copy this formula right here, changing all of the a's into a's and changing all of the b's into b plus pi over 2's. So I would have the sine of a times the cosine of not b, but whatever I'm adding here, which is b plus pi over 2 in this case, plus, for this plus, the cosine of a times the sine of whatever I'm adding here, b plus pi over 2. Okay, but that's still not my cosine angle addition formula. Right, but I haven't used this last fact here. The cosine of b plus pi over 2 is exactly what I have written on this side of the equation. And this last fact tells me that that's the exact same as the negative of the sine of capital B in this case. I'll leave my sine of a all alone, and then I'll rewrite the cosine of b plus pi over 2 using this fact as the negative of the sine of b. I'll leave this cosine of a completely alone, so I still have plus cosine of a, and I'm going to change this sine of b plus pi over 2 using this fact to the cosine of b. Wait, what just happened at the end there? The sine of b plus pi over 2 looks a lot like the right-hand side of this identity, playing the role of the t as a capital B, and this identity tells me that's the exact same as the cosine of t, but playing the role of t is this capital B. This positive times this negative makes this entire term negative, so I have the negative product of these two guys plus this guy, or to write things a little bit differently, I have this plus this negative thing. I have the cosine of a times the cosine of b from this term, minus, because I'm adding a negative number, the sine of a times the sine of b. And sure enough, that's exactly what I was hoping I'd come up with, the cosine angle addition formula.